Hi everyone, welcome back to Fundamentals of Engineering with Farhad. Let's review an interesting example in structural analysis in seismic design related to SE and P exam question. So in this example, we have like a three-story building with the lateral strength of our given like first story has like 8 tons, 9 tons, and the third one has like 10 tons of lateral strength respectively. We want to answer this question like if there is any soft story in this building or any weak story or there is no soft and no weak story. Let's review the procedure how to solve or answering such problems in professional engineering and structural engineering exams. So for the first, let's jump to the definition of weak story definition. So if you remember, we're talking about if you have like a four-story building with a stiffness of K1, K2, K3, K4 for each story. If a story lateral strength is less than 80% of the story above, if any of this story in terms of their lateral strength is smaller than 80% of the story above, that's called a weak story. With this definition in mind, let's jump back to our a problem. So it just says if a story lateral strength is less than 80% of the above story, we by definition we call that a story like a weak story. So in our problem, we have 8 tons for first floor, 9 tons, and then 10 tons for third story or the last story. So in this case, let's begin with let's check with the very bottom one. So 8 tons should be higher than 80% of the above story in order to not not having a weaker story. So 8 is definitely higher than 80% of 9, which is the above story. That's 7.2. So the first story is not a weak story. Let's double check the second story. So the second story is lateral strength is 9, and that's also larger than 80% of the last story. So in this building, there is no weak story. So in terms of the weak story, we didn't find any weak story in this problem. But for soft story definition, we need to jump to like a building like having K1, K2, K3, and K4. So if the for the definition of soft story definition, if the stiffness of the first floor is less than 70% of the story above, or the stiffness of, for example, first floor is less than 80% of the average of the three story on top of it. So in any of these two cases, we will call the our story like a soft story. So for example, if we call it for consider it for K1 first story, we by satisfying any of these two conditions, we'll say that first story is a soft story. So let's jump back to our problem. If a lateral force apply, just consider for the very first floor, if you just apply a lateral seismic force at the level 1 and then it just move like this, and then it's a stiffness for such a structure, one fixed one, a such condition, it's like the stiffness is 12 times EI over height cube. So our height is provided, our EI is provided, and if you look at our structure, it has two of these shear walls. So K of story is two of them. That's make it like 24 EIH cubed. So then based off soft story definition, if the stiffness of any of the floor is less than 70% of the top story, for example, K1 is 2 of 12 EI over H cubed. That's 24 EI over H cubed for the first story. And K2 is again 2 times 12 EI over H cubed with the same height and EI. That's also 24 EI over H cubed. And the last or the top story is 2 times 12. This time EI is 1.5. It's 1.5 EI or 50% higher than the two others. Then over the same height which is provided. And if you do the math, it just gives you for K1 that's 24, for K2 that's 24, for K3 that's 36 EI over H cubed. So for first story K1 is 24 EI over H cubed. If it's bigger than 70%, that's not a soft story. So K1 is definitely 24 EI over H cubed is definitely higher than 70% of the same stiffness. So first story is not a soft story. Let's review or check the second story, and 24 EI over H cubed, if it's larger than 70% of K3, which is zero point 0.7 times K3, which is 36 EI over H cubed, and that make it like 25.2 EI over H cubed, which you can easily see 24 is less than that, so that's a soft story. Likewise for the third story, that's not soft also because there is no story above it. So the second or the middle one is a soft story based off our calculation. So this is not soft story. Second one is a soft story, and this is not soft story. So the second one, because 24 EI is not smaller than 25.2, 7.70% of K3, that's a soft story. So now again, let's review our problem again. We have like based off our calculation for lateral strength, there is no weak story in our building, but based off stiffness, we find second story is a soft story. So the answer is there is a soft story in this building. So answer A is the correct answer. Thank you. We'll solve more multiple choice question in next videos.